This is video help for problem 7.9. We start with our MR signal. Remember, it came from ddt or minus ddt of flux. So we had omega 0 from the time derivative. We have v sub s from adding up all the spins over the volume of the sample. It's considered to be small enough or whatever such that the magnetization and the fields are constant. So it just gets, this integral just gives us v sub s because nothing depends upon space. In that approximation, I have T2 decay. I have, remember, our m dot b dot product that came from ultimately from the flux and reciprocity, where now we can just think of the magnetic field due to the receive coil in reciprocity permeating the little loops that make up magnetization. And only the perpendicular part of the dot product, contributes, because that's the only part that's precessing at this huge frequency. The longitudinal part is not. And this is the precession sign, showing the precession in the XY plane usually. Well, in part A, the only thing that's changing is the receive coil, so it's just this factor. In part B, the only thing that's changing is the tipping angle, sine alpha, and alpha is proportional to your transmit pulse. And if B1 transmit were to give pi over 2, then half of this would give pi over 4, and you certainly know how to figure out the sign. And now we finally come to part C, which says, oh, you're going to see the reduction in A is bigger than in B, so it must be better to have a nice homogeneous receive coil that doesn't change than as a bigger factor, a bigger reduction, than a change in alpha, because sine of that alpha doesn't have the same effect. You're going to get this reduction smaller than that reduction. But let me just tell you two things. One is, we want all the spins to be tipped exactly the same amount, because we only want inhomogeneities to be due to the number of protons there and the tissue environment that they find themselves in. And we often have a real small receive coil, just sensitive to a small little volume to pick up, we're trying to dig out a small signal. So with those two thoughts, I think you'll be comfortable with part C.